Hello everyone, welcome back to ENR 123 car project tutorial videos. In today's video, we'll generate the time and the required material to 3D print a part. So as you guys notice on your homework sheet, it asks you for the total time in order for it to calculate the total task and how much material this will be required to 3D print these two parts, or however many parts you have. This can be replicated to in any assembly or a different part. So I have my car body here, and let me pull this up. What I have is, right, everyone should have configurations, and I actually have a main configuration that includes both of them, and I have a passenger side, right, because you can't really 3D print this whole thing. You can, but it's going to require a lot of support material, right? So how to 3D print, it's going to go up in the Z direction. As we can try to replicate that, and let's say, let's do, right, so it's basically going to 3D print like this. And as you guys notice, right, there's going to be some overhangs, right? There are angles. So in order for the 3D printer to get there, it's going to actually have to fill all this empty space with support material. Support material is also expensive, so you always have to find the most efficient way to 3D print this to utilize the least amount of material. So again, if I go up, right, that's a lot of support. That's a lot of empty space. So that's a lot of support. So let me exit out of here. So again, I have my driver's side, my passenger side. Everyone should have this in their car body. And as you guys work on the new car bodies, you're going to do the same thing, right? Two different configurations or three. I just have a third one that's called main that includes both of them. What I want to do here is I want to generate two STL files. So an STL file is a file that the 3D printer software can open or can read, and it can get all that data from. So what I want to do here, just like a SolidWorks part file for a 3D printer, it's an STL file. So right, for this it's a PRT. For the 3D printer software is an STL. So I'm gonna go to the driver side. I'm gonna start with my driver side, right? And what I'll do here is I'm gonna go to File, Save As. I'm gonna throw it on my desktop, or you can create a new folder on your flash drive. Again, this is just to show you guys how to do it. Wherever you feel like placing this, right? You don't want to lose the STL file because that's where you're going to open it from your software. So if I do an STL, and I already have it saved, but basically if you go to the drop down menu, Save As Type, it's going to be an STL right here, right? So right here we have our SolidWorks part file, and it's just going to be a different format in STL. So I'm going to select that. Again, I've already saved this, so I'm going to have to click Save, click Yes. All right, so I have my driver side STL generated. If I go to my desktop, so it's called car body right here. And I should probably, let's do this. I'm gonna go to my desktop because I have my assemblies called car body. So let me delete that. Just to make it easier, I'm just gonna do file, and you can just rename it. You don't have to delete it. I'm just gonna do desktop. I'm gonna call this one driver side. Save. And it's telling you the triangles and the file size, file format. Click yes. Gonna toggle to my passenger side. Gonna do the same thing. File, save as. I'll just go to my desktop. Jump to STL. Right. Save as type. It should be an STL. And that should, let's call that passenger side. Click save. Click yes. All right, so now we have our two files on my desktop. I have my driver's side, my passenger side. They're both STL files. That's what I need. So I'm just gonna, if I go to my start menu and you're on a school computer, and you want to open up Catalyst. So okay, CAT. So it's a Catalyst EX version 4.5. Again, depending on when you're watching this video, this might be a later version or an earlier version. But Catalyst EX. So I want to open that up. Again, the best way to do it is if I go in my start menu and I just start typing Catalyst, it will show up. I find that's the fastest way to open it, Catalyst. If another way to do it is if you start menu, if you go to the C, right, there's Catalyst EX 4.5. You can click here and open it up from here. This is the welcome. I'm just gonna hit cancel. And this is the 3D printer built platform, right? So you have X, Y, and Z. And that's when I want to start importing. So it's telling me my 3D printer, so it might be different depending on the department. Telling me how much modern material I have in there, so 4.38 cubic inches, and how much support material, so 36.43 cubic inches. So what I want to do here is I want to go to File again, just like Microsoft Word or PowerPoint or SolidWorks. I want to go to open up that file, right? So I saved it on my desktop. I want to go to File. It's an STL file. So I'm going to go open STL. If it's for some reason it's toggled somewhere else, you can always just toggle desktop. And I want to import my driver side STL. Click open. Again, so now you start want to think about the orientation, right? If I print it this way, it's going to have to fill all this void with support material, right? It's going to use up a lot of support material. So we don't want to do that. So let's reorient this to minimize how much support material we're going to utilize. So I want to do, first thing I want to do is I want to rotate it about the X. Right, so this is my X. I want to rotate about that X axis. Again, if I do it this way, it's gonna have to fill all this void. Click X again. So that works, right? Because this void here it's not gonna have to be filled up because there's nothing on top of it. Again, if you start thinking about the car body, right? If we had the full car body and it was printing this way, then it would have to fill the whole thing up. That's why we divide this up. And this orientation is the best orientation to print. So I can see that it's overlapping by a tiny bit. So what I might want to do here is I might want to add an angle. So let's print this at a 45. And I want to do it around about the Z axis, right? So this is my Z. I'm rotating this way, clockwise or counterclockwise. Let's do that. Okay, so I can fit two that way, just because it overhangs a bit. You can always scale it down, but for this we want to print it one scale. What I want to do here is I want to add to pack. So it's going to go slice. It's basically calculating how much material, how much support it's going to use up, and how much time. So you just give it a bit for it to go through the process. Right, and right here, you know, it's done. It says added CMB. So if I go to my pack, I have my first part, and it tells me that it's going to require 2.4 cubic inches of modern material, and it's going to require 1.19, right, cubic inches of support, which that's good, right? It's not using up a lot of support, and it's going to require 3 hours and 36 minutes. Again, the time is always an approximation. It gets close to it, but as you might know with 3D printers, the time is not always spot on. Usually the material is very close Time-wise, it might be a bit off depending on your printer speed and all that. But it's still a really good approximation of how long it will take. So at this point, I only have one side of it. So let's go back. Now I want to basically, I have this pack already, so I know how much material this will require. So I want to do the same thing to the other side. So I'm just going to go back to File, Open STL. And I believe we did for this one, it was the driver side. Let's do Open STL. I'm going to import my passenger side. So the orientation, that works, right? I want it this way. Again, just like we've talked about, there's only overhangs here, right? It's going to fill in the support here for it to build that angled side of it. And then, so what I want to do here, again, I might be overhanging a bit, right? That's the line, that's my limit. I can see that there's a bit of overlap, so I don't want that. The printer is not going to let me, if I try to add to pack, it's going to give me an error. So let's do that. Let's go to orientation. Let's see. Right, the STL extends outside of the build envelope and acts place for the orient reduce STL scale or section the part. Again, I'm not going to scale it. I want it to 1:1. So I'm going to go to orientation. And in this case, I'm just going to rotate it by my Z. That works, right? It's within those constraints. I'm going to hit add to pack. Again, doing the same process again with the passenger side. And I'm going to wait. It's just like a CNC, created a toolpath and everything, right? So it's done generating. So does CMB does not fit as the CMB zone part overlaps? Yes. The reason it's always going to put in the center, but if I move it a bit, okay, that's good. Now it's not overlapping, right? If you get these hash marks, then that means it's overlapping. It won't let you print it like that, right? But if I move it away, then I have both sides and I can print both sides. So you might get that error depending if the printer always tries to throw it in the center. You can always move things around, right? We can move this here, maybe print some smaller parts all the way around, right? We have all this empty space here, but we have space. You can always rotate stuff here if you want. I just like to do it in my orientation, but you can always rotate things here. Right now I have my model material, support material, and time, so this is going to take 7 hours and 20 minutes. And the name is the pack driver side. You can always call this last name, whatever your last name might is. Maybe first name and car body. So right, I mean, if I really want to print this right now, I can just hit print, and it will start printing. We'll actually send it to the printer. You have to go to the printer and click start. But again, you can always save this. Save as. Save it as an STL that combines both. You can save the pack, right? So you don't want to save the STL because that will just only save the STL. So if you want to save the pack that includes both, you can hit save as, and that's your CMB file. So that's where you want to save. Once you save that, you can hit, when you click open insert CMB, it will just import both sides, your orientation, everything in there. So we'll do material, so you don't have to generate this again. But that's all I have for Catalyst. Again, it's pretty straightforward stuff. Basically, going to SolidWorks, generating STL files, and then jumping into Catalyst, importing those, generating some tool paths for both parts. Or I mean, you can have as many parts as you want, right? You can have as long as it does not overlap. I know the 3D printer is smart enough to know to not print overlap parts, right? You can get it close. Right, you can be very close, but there's a limit. Again, this is what you're looking for to generate the or to provide you with the answers for your sheet, right? Your model material support and time. And that is it. So thank you for watching.